Okay, so the question was, if x minus 4y is 15, we want to find the minimum of x squared plus y squared. Now, we had a problem very much like this in the homework. But I think only one person did the homework. So that's why we're having to spend a lot of time in this class instead of talking about what's coming up next. Okay? That's if you do the homework. And that's kind of important. But okay, so we want to find the minimum of x squared plus y squared. Now we know how to find the minimum or maximum of a quadratic function. The vertex of the y versus x parabola occurs on the axis of symmetry. And we have prominently done this in the videos and the classes. And the axis of symmetry how to find the axis of symmetry? For the reasons I've talked about and the reasons you really kind of want to know so you can apply it in your pre-calculus course, occurs here. I'm not going to repeat except to say that this is where the thing is 0. The graph is a parabola which is symmetric about a line right through the middle of it, basically. Vertical line. And the vertex lies on that line. And the zeros, if they exist, are at equal distances on the other side of that line. Well, the thing that gives you equal distances on the other side of the axis of symmetry is the plus or minus sign. You get two possible results if you have two zeros. One from adding this discriminant, the square root here, okay, the square root of the discriminant, and one from subtracting. Now, what's halfway between what you get when you add this and when you subtract this? Well, if you add a number to b, or negative b, and subtract the same number from negative b is right in the middle. And from that idea, negative b over 2a has to be the equation, it has to be the x value on your axis of symmetry. Axis of symmetry is a vertical line, x equals negative b over 2a. Now again, we've said this many times, so you really need to review the videos and so forth. But anyhow, here we have this. Now, if we want to get, okay, and the maximum minimum values on the axis of symmetry. That's at the vertex, because simply if the parabola opens upward, the minimum value of y is going to occur here. If it opens downward, then you're going to have a maximum value of y at this point. That's as big as y gets. Y goes this way. So here, that's as low as y gets. Here, this is as high as y gets. Now that's something you really have to understand if you want to master the graphing of quadratic functions. And something we universally do in a pre-calculus course, at least here we do. Not sure what everybody else does, but I'm pretty sure most of them do that. Okay? And I really think they should if they don't. Anyhow, So we have this, and we want the minimum of this. Now, some people actually did this with, in this problem. We solve this for either x or y, and then we plug that expression in for x or y, whichever we solve for here. Now, if you want to keep it where y is a function of x, so you want to use the quadratic formula with x is in it, you're going to solve this for y. It's okay to solve it for x, but then you kind of change your variable in the quadratic formula, and I'll do a little of that because at least one person did that. But I'm going to solve this for y. Although it's pretty natural if you're going to solve this for a variable to just add 4y to both sides, and you got to solve for x, right? And you could then take the 15 plus 4y you get here and plug it in for x, and you get a quadratic expression for y. Okay, well that's okay, but I'm going to do it the other way just to make it as clear as possible. Now the numbers don't work out as nicely for y, but that's just the way it is. Okay, so I really want to see you in this class explicitly state the way I've always done when I do examples, what operation you're doing to both sides of the equation. So, if you add negative x to both sides, that means you could write x minus 4y minus x equals 15 minus x. Here's this side, you subtract x. Here's this side, you subtract x. When you do that, x minus x is 0, so you get negative 4y equals 15 minus x. Then, and what you're doing here is you just simplify the left-hand side. X minus x is going to give you 0. Then, on this side, you divide both sides by negative 4. You divide them by whatever number is in front of y. You wouldn't divide by 4 because that would give you negative y and you'd have an extra step. But you could get away with that as long as you remember to then multiply by negative 1. But it's easier if you do this, and remember that's a negative 4 like I almost did. Okay? So now we've divided both sides by negative 4. Everybody's going to want to cross out the negative 4 here and the negative 4 here. I don't do that in this course. I don't want you to do it in this course. I can't stop you, but if you do it that way and mess it up, I'm going to be very unsympathetic and degrading, and I'm going to call you on it if I see you do it in class. I'll be nice about it. Okay? I don't start using the cattle prod until after midterm. Seriously, I'm not going to get after you for it. I'll just keep reminding you. You're the one that has to get after yourself, right? Okay. I wouldn't use the cattle prod even if it was legal. Okay? Don't want to be punitive. Okay, but anyhow, you need to understand fractions well enough to understand that I could write this side as negative 4 over negative 4 times y over 1. Okay? And that equals 15 over negative 4, which I'm going to just take a chance and write as negative 15 fourths, and then plus x over 4. I mean, it's negative 1/4 times 15 minus x. Comes out this. But your division by a number distributes over addition and subtraction in your numerator. And we're continuing the simplification. -4 divided by -4 is 1. So that's 1 times y over 1. I'm going to put this in form x over 4 minus 15 over 4. And we're going to continue. 1 times y over 1 is y over 1. And y over 1 is just y. So now we've solved for y without using cancellation. This is what cancellation means. Okay? Get this. Okay? Now, we square this, so we're just going to kind of do that before we go on. To square this, there's a special formula. And I want to emphasize that we use the distributive law, not a special formula. Because again, in this course I don't like to assume that people know the special formulas. Actually, we start studying the special formulas, I think in the next homework assignment or the one after that. Okay, so we have this. So this is x over 4 times x over 4 minus x over 4 times 15 over 4. Okay, because it's x over 4 times this and x over 4 times this. Now we've done distributive law, so I'm doing it a little shorter than usual. So you might want to review how we've done that. But what we get is this times this times this, and this times this, and this times this. So, if we put all this together, this is going to give us x squared over 16 minus 30x over 16 plus 225 over 16. Now, we want to minimize, and we're going to use this part of the board over here. Okay. Again, no, well, our expression is going to be quadratic in x. Okay, because we've got an x squared term, we've got x terms, and we've got numerical terms. I'm going to write it out in a minute. But we know that that gives us a parabolic graph with a maximum or minimum, maximum in this case, minimum in this case, at the vertex. Okay, so so there it is. Now 30x over 16 reduces to 15x over 8. You divide both the 30 and the 16 on 4, but I'm going to leave it in this form. Because what I want to do now is, maybe I don't want to do that. What I really want to do is factor out a 1/16, but that gets complicated with the x squared. So I'm going to do the arithmetic here. And that's going to give me I don't want to get into all that arithmetic. It's just going to distract you. Let's say this is quadratics. Use a quadratic formula. Find the zeros and the axis symmetry, etc. Do that. Now it's going to be a little confusing if I say let y equal this. So instead of y, I'm going to use z. So we're kind of thinking we have a z equals ax squared plus bx plus c. And we want to solve to find the value when z is 0, because that's how we find the zeros. Now before we do that, so let's write it out. We get x squared plus x squared over 16 minus 30x over 16 plus 225 over 16 equals 0. We want to solve this equation for x. What do you see in this equation that tells you the very first thing you need to do in order to solve it? We multiply by denominators. Because in a fraction, if we multiply by a common denominator, we're going to clear out all our denominators, and we're not going to have these fractions to mess with. Well, I was hoping to have room to write it out down here. If we multiply all this by 16, what are we going to get? Okay, can you read this okay? Can you do that? Can you multiply all this by 16? Okay, do that real quick.